Hey guys, this is gonna be the little review over the naming that you guys will have your little quiz over tomorrow. This is the PDF that I uploaded to Google Classroom. I do recommend you look through it. I'm gonna be going through most of it in this little video. So what I want to start with is whenever you see either the name or you're seeing your formulas, okay, you got to ask yourself, I think ultimately, is there a metal involved? Okay, and so that question right there tells you which direction to go, even on this flow chart. Okay, if there is, you're treating it with Ionic rules. Okay, which there's three main rules with that, and that has to do with polyatomics, your stock system, and then just your regular old ionic compounds. Okay. If there is no metal, then we are going to swing it over to this side where we do have our molecular compounds, two nonmetals, and we're going to be using prefixes. Or we're going to recognize that there's a hydrogen at the beginning indicating that there is an acid. Or if we're looking at the names, we're going to find that the word acid is somewhere in there. Okay? So these are, in my opinion, these are the two big routes that you need to go through. And once you decide if there's a metal or not, it's kind of straightforward from there, okay? Okay, so we're going to focus in on the Ionic rules. I would say most of us were needing a little tutorial over Nick the baby camel thing, okay? So what we're seeing here is that when we know that we have an ionic compound, our usual or the regular ionic compound, okay, is going to consist of having a cation and then an anion ending with "ide." Okay, cation, anion ending with "ide." And what we're going to see is we're going to see subscripts. Okay, we're going to see a metal and a nonmetal, and they're going to be switching their charges. Okay, so if we have something like calcium chloride, okay, we know that calcium has a +2 charge, chlorine has a -1 charge. We crisscross those and we end up with CaCl2. So that's the straightforward how you guys are going to be doing your regular ionic things, okay? Okay. When we are dealing with stuff like our stock system, okay, stock system right here in green, we need to be thinking of your multivalent cations. So that's a lot of your transition metals, okay? And with stock system, if you're reading your names, so let's just say we have lead 4 oxide, right? We see this Roman numeral, we know that we're dealing with this stock system. The way that you're going to use that is this is your charge on your cation, okay? So this 4 means you have a +4 on this lead. So you're going to treat it like you do your typical ions or your ionic compounds. And you're going to crisscross those charges. We end up with Pb2O4, and we know that we need to simplify those down. So you actually have PbO2, right? But ultimately, what I needed you guys to get from this is that those Roman numerals tell you the charge. So don't sit there and try and guess them. I know I told you guys to memorize a bunch of multivalent cations. Get familiar with them. I think that's a friendlier term. Become very familiar with them. But ultimately, you're going to be able to figure out what those charges are usually by looking at your anion, okay? Because your anions have kind of the set charges on them, okay? And you can kind of rely on that to tell you what you've got. So this is if you are given a name. Let's just say I was given something like the PbO2, and I said, name that. I think that was even on your last assessment. You have two options. So you can do the reverse crisscross, but what we're going to see is that's going to fall apart right here. I'm still going to show you. So if we reverse crisscross, right, we end up seeing that Pb would have a +2, which we know is an option, but we would see that this oxygen has a -1. If you look at the periodic table, oxygen's in group 16. Oxygen will never have a -1. So this is where it falls apart. And this is where you want to actually start using the other way to figure out your charges, okay? The most reliable way is you look at your anion, okay? Oxygen has a -2 charge. -2 times 2 is equal to a what? -4. We now know that this has to be a +4 in order to keep it electrically neutral. Okay, we need to balance it out. And therefore, this 4 is split between one lead ion. If there were 2, we would do 4 divided by 2. If there were 3, we do 4 divided by 3. Whatever we got, okay? But here we have a 4 divided by 1, which tells us that this is a +4. So now you can actually write, oh, that's lead 4 oxide. Okay? So be ready to kind of go back and forth between those. Our last little bit on this side of the chart. Okay, so that's going to move us on to the part that I think a lot of us were needing help on, and that's going to be our polyatomics. So I know I kind of shrunk that up right there, but we're going to be messing with this part of the picture, okay, your polyatomics. And I'll just go ahead and rewrite that because I think that's going to help you the most. So for our polyatomics, after realizing that you do have a metal involved, and now you're actually seeing a combination of a nonmetal with an oxygen, right? So looking for those oxygens usually, okay, but you also have a few exceptions to that rule as well, and you guys have seen those. But when you have your polyatomics, your big thing is that you got to know what your 8s are, your 8s are, and all that stuff, and that's where a lot of us are struggling. So what I recommend is go ahead and write that sentence, that crazy sentence that I've told you guys to memorize, which is Nick, the baby camel, and then write 8, and put a circle around that 8, okay? Because that's going to tell us a little hint in just a second. Nick the baby camel 8-inch clam. I think during a lecture I might have said clams. Please do not put clams. That will ruin everything. So it is clam, okay? He ate inch clam for supper in Phoenix. Okay? What this sentence does for you is it points out all of your 8s, or the most common 8s, okay? So if these are your 8s, you're now going to also use that information in order to find your other guys. If we're starting at 8 and we increase our oxygen, okay? If we increase an oxygen, we're going to go up to a per something 8, such as perchlorate, okay? And then we can go down to a chlorate, which is coming from our sentence. We can drop down another O to be chlorite. And then I can drop down 2 O's in order to become hypochlorite, okay? So the reason why I've made such a big deal about using this sentence is because if you can figure out 1, 2, 3, 4, 5, 6, 7 of these polyatomics, and they're all your 8s, right? We're all right there. You now have 7 times 4, right? 7 times 4, so you're going to have 28 total polyatomics that you now have memorized, okay? By just doing a little bit of thinking. So, back to these original words, okay? These are all your 8s. So what they stand for, I'm going to go ahead and write next to them. This is nitrate, okay? This is bromate. This is carbonate. iodate, chlorate, sulfate, and finally phosphate. Okay, and one that we kept seeing in class was permanganate, and I would just get used to that one too. So permanganate. We're gonna write out that formula here in just a little bit. Okay, so having these, okay, these are all your 8s, right? So with these being 8s, we now know that once we get those formulas, we can add an O to make it a per nitrate, okay? We can take it down an O to make it nitrite, or we can take it down 2 O's to make it hyponitrite. And you can do that for all of these different polyatomics right here, okay? So let's go ahead and write out the different formulas that we've got. So nitrate, okay? The way you use this sentence, okay? Consonants, which are your non-vowels, A-E-I-O-U, right? So consonants, anything that's not a vowel, is going to be your number of oxygens. Okay, and I'll show you what I mean when we get up to the words. Your vowels tell you your charge, and they're all negative charges, okay? So Nick, if we look at this, we know that we're dealing with nitrogen. So we're going to start with nitrogen. We know we are going to have oxygens because it's a polyatomic. Now we're going to actually look at what we've got. We have 1, 2, 3 consonants. So therefore, nitrate is defined as NO3. And then we have 1 vowel. So that's going to give it a -1 charge. Okay? Let's look at the next one. We have bromate, right? So we know that we're dealing with bromine. So we're going to put Br. We know we're going to have some oxygen. You're going to count up your different consonants, and you have 1, 2, 3. Again, so you're going to have BRO3. Count up your vowels. You have 1. So this is also -1 charge. Okay? We get to camel, and this is for carbonate, so we know that we're going to have CO something. Let's look at those consonants. We have 1, 2, 3. So this one has a 3 as well. However, you have 1, 2 vowels. So that indicates that you have a -2 charge. Okay? And you could continue them all the way down. I'm just going to, for time purpose, I'm just going to go ahead and do them. You can pause the video at this point and then try them on your own, and then you can check it. But this is going to be IO3 minus ClO3 minus SO4 2 minus, and this one will be PO4 3 minus. Okay? And so now that we have these things, let's look at phosphate. Okay? Oh, permanganate is also MnO4 1 minus. Okay? And that's just one to just kind of put in the back of your brain. All right, but back to phosphate. So if I know that PO4 with a 3 minus charge is phosphate, right? We can now use our little spectrum, I call this thing the spectrum, okay, to figure out what your other things are. We can get per phosphate by adding an extra oxygen. So this is going to be PO5. Your charges never change. We can go down to get phosphite by taking away an oxygen. So we're going to say PO3, still a 3 minus charge. I can then go all the way down to hypophosphite. And this goes down 2 oxygens from our phosphate. So that's going to be PO2 with still a 3 minus charge. So once again, you're using this main sentence, the stuff that's in red right here. Okay, you're going to use that sentence to define these different 8s. Once you have the 8s, remember to use your consonants to tell you the number of oxygens. Use your vowels to tell you the charge. Once you have figured out these formulas that are in green, okay, you can then use the spectrum to figure out any variations of these guys. And that's the way to use your polyatomic sentence here. Okay, so hopefully that helped. Once you have your polyatomic, please remember that you go back to basic crisscrossing with your ionic compounds. So let's just say you had something like calcium nitrate, right? Nitrate has a -1 charge, calcium has a +2. We would still crisscross, and you would have calcium and then NO3 with a 2 on the outside. Okay? So don't forget to still crisscross at the end. Okay? This is only half the battle. So hopefully this helps with the ionic part, which I do feel like most of us were struggling with that part the most. So if you need to rewatch this again, I would write it out, practice it, practice some of the other ones. I'll have the key posted hopefully by about 9:30 tonight. Okay, the other part that I was going to go over has to do with if there was no metal. If there is no metal, then you're dealing with either a molecular compound where you just have 2 nonmetals, right? So 2 nonmetals. And you're going to be using your prefixes, okay? So if you have 2 nonmetals, and let's just say I give you the formula, such as this one right here, P2O5. You need to look at your subscripts and use the prefixes, okay? The only special rule on your prefixes is never use mono on your first element, okay? So P2O5 is going to then become diphosphorus, 2-phosphorus, pentoxide, all right? And as you can see, I had pentaoxide. Whenever you have that issue where you have 2 vowels, you are going to cross out the A. And so it's just going to kind of flow that way. So diphosphorus pentoxide. All right, so that's easy enough. Then if you see the words, okay, let's just say you're seeing the words, remember that first one, if there's no prefix on it, it means 1, okay? And then everything else, you should have prefixes on it. If I had carbon monoxide, okay, that means 1 carbon, that means 1 oxygen, and you're done, okay? So I feel like not too many of us were struggling with that part. If you do need some more help, you can message me. The last little bit that we covered, I think last in our notes, is when you have an acid, all right? So once again, if you're dealing with an idea that you do not have a metal involved, okay, you're going to look to see the nonmetals. If there is a hydrogen at the beginning, you're dealing with an acid, most likely. Okay, so when you have an acid and you are trying to write the formulas, still treat it like an ionic compound, meaning you are going to crisscross charges. That hydrogen will always have a +1. This anion charge is going to be the one that changes. Okay, so for example, if I had hydrochloric acid, right, this is a -1, this is a +1, they crisscross nicely, okay? If I had sulfuric acid, which we'll get to those in a minute, H is still that. Sulfate had a 2-, so we're going to still crisscross for our acid. So we would have H2SO4, okay? So don't forget that ionic writing is still going to be happening, okay? All right, so now we're looking at our acids. If we only have 2 elements, it's called a binary acid, okay? And so with that, you're looking at hydro, ending with ic, acid. They all end with ic. If you're looking at a bunch of names, you're looking to see if they have hydro. This is not hypo, okay? This is hydro. The minute you know you have hydro, it is literally 2 elements. So you're just going to put an H, whatever your anion is, and that's it. Okay, so you can, the most common ones are in group 17, but you can go everywhere else. So you could have hydrosulfuric acid, which would look like H2S. Okay, so just be aware of that. The ternary ones are the fun ones, in my opinion. These, we have a nice little saying, and it's "ick, I ate a humongous bite," which is fine, but you got to know how to use it. So the way to recognize that you have a ternary acid is you're looking for oxygen somewhere in there, okay? Once you have oxygens in there, you know you're dealing with your polyatomic. So your first step is figure out which polyatomic you have, okay? So you're going to refer back to your Nick the baby camel sentence, okay? And you're going to figure out which polyatomic you have. Once you figure it out, okay, so let's just say I have sulfuric acid, okay, and that's working the other way. So let's put the actual formula right here. So I figure out that I have this SO4, and I know that this 2 came from a -2 charge. So this right here I know is sulfate, okay? The next step is you ask yourself, is it an 8 ending or is it an I ending? Once you've decided, so for this one we have an 8 ending, then you're going to use your sentence. So use the sentence, okay? This "ick, I ate a humongous bite." I'm going to zoom in on it again. What this is telling you is that if you have an 8 ending, and that includes a per 8 ending, you're going to end it with "ick" before you say acid. If you have an I ending, including your hypoites, you're going to end with an us or else ending. So what that looks like to you is right here, since I had a sulfate, okay, I am now going to change that to be sulfuric acid, okay? So I went from formula down to this. Now we could have gone from name to the formula. Let me erase that real quick. We could have gone from the name to the formula by analyzing that. Is there a hydro? No. So we know it's a ternary acid. So that's when we focus in on whether that ick makes sense. Because if you notice, your binary acids also had the ick ending, okay? But they had a hydro to begin with, which made the difference, okay? So this one, no hydro, so we know it's ternary. We have an ick ending, so we know that we're going to take this little sulfur, we're going to make it into a sulfate. And that's where you're going to use your sentence again. You figure out what you've got. So I say, oh, that's SO4 with a 2- charge coming from the word supper, okay? And since it's an acid, I know that I'm going to have a hydrogen at the beginning. Crisscross charges, you end up with your H2SO4. And that's it. So hopefully this helps some of you guys. Go back and forth to the areas that you need the most help on. Message me if you need any more help. Like I said, I should be getting the key to your guys' packet up here soon. Okay, so thank you for being patient, and see you tomorrow.